Hi, lesson 18's checkpoint. So we're going to start with question 10 and then we're going to jump to the example proof. So, given triangle ABC is similar, that's what this symbol means, is similar to triangle DEF. And the length of AB is equal to 2, the length of BC equals 4, the length of AC equals 4, measure of angle C equals 29 degrees, length of D equals 3, length of EF equals 6, and the measure of angle F equals 29. What is the measure of DF, segment DF? So we know that we have similar triangles and we're looking for a length of a side, so we need to find our corresponding sides. So AB, first vertex to the second vertex, is going to be corresponding to DE, which is the first vertex to the second vertex. And then BC is our second vertex to the third vertex, is going to be corresponding to EF, which is our second vertex to the third vertex. It's the side length from our second vertex to our third vertex. And then we are left with C to A, which is the third vertex to the first vertex, and F to D, which is the side length of our third vertex to our first vertex. So now we have our corresponding sides marked, and we want to find DF. So we need, which is right here, we need our scale factor, K. We need to have it set up, and I'm always going to use the triangle that has the missing information for my reference, my first triangle used. So I want DF to be in the numerator, and its corresponding side is CA, and then I'm going to use one other group of corresponding sides that has all of the information given. So if I look at DE, I want the scale factor for DE compared to its side A, its corresponding side AB. Now, by substitution, we know that DF is our missing information, the one that we know, the one that we want to know, and CA's length is 4 by substitution, and the length of DE is 3 by substitution, and the length of AB is 2. And now we're going to use the transitive property, and this is how the transitive property works. We have x divided by 4. That's equal to our scale factor, K. We also know that K is equal to 3 divided by 2. So the transitive property says I can cut this middleman out since this is equal to each other. Since the first is equal to the middle and the middle is equal to the last, that means the first one has to equal the last one. So we're cutting out the symbol K, and we're going to set up using our transitive property, x divided by 4 equals 3/2. Now 3/2 is a number. I'm not going to do anything with that number. I'm looking at x divided by 4. I'm going to use the multiplication property of equality and multiply by 4. So both sides. Now 4 times x divided by 4. We always multiply our numerators. So we have 4x divided by 4. We multiplied it there. Equals 3 times 4 is 12 divided by 2 And 4 divided by 4 is 1. So then we have 1x equals 12 divided by 2 is 6. So we have that our side length DF is equal to 6. I also want to point out that if you had used power of observation and noticed that this was 4 and this is 4 as well, and this was 6, and what was our corresponding sides? Well, BC's corresponding side was EF. So the other 4's corresponding means, and AC's corresponding side was our DF right here. So that has to be the same number. Since these two numbers are the same, these two numbers would have to be the same because they're similar triangles. This one is an isosceles triangle, so the corresponding sides in this one would have to be also create an isosceles triangle. So that's just the power of observation helping you answer that. Now 9 is set up similar to 10, except you're finding the measure of an angle. So find your corresponding angles. And we're going to step through our proof. So read and complete the following proof by ordering the given statements. The following is a proof of side-side-side similarity theorem. So the side-side-side similarity theorem deals with all three sides. So construct point G on DF so that it is the midpoint of blank. So we have, and then construct point H on segment EF so that it is the midpoint of segment EF. So if we look and compare the first statement to our second statement, pretty much the same one. So G on segment DF so that it is the midpoint of segment DF. So G is the midpoint of our segment DF. So our first blank is segment Okay, well, there's not a number there. Just know that that is segment DF. Construct triangle ABC such that the length of AB equals the length of GH. So they are stating that AB, this length, has the same length as GH. Blank equals GF and BC equals HF. Well, BC right here is going to equal the same length as HF, and our GF right here is going to be the same as AC. So this one's AC. So now, due to the construction in step 3 and the definition of congruent segments, segment AB is congruent to segment GH, segment AC is congruent to segment GF, and segment BC is congruent to HF. So if we hadn't marked these out and used elimination to figure out that that was AC, another way is to look at the next step ahead and notice that it's right here, AC. They're stating that AC is congruent to GF. So if they're stating that, that means the length of AC had to equal the length of GF back in step 3. So now step 5, since all three pairs of corresponding sides are congruent, blank by the side-side-side congruence postulate. So congruence postulate means that these are the exact same triangles. So now we have to set up the right order of triangles. So we need to know that corresponding sides will be matched up. So I'm going to list it out. A to B, B to C, C to A. So I need to go in that same order. G to H, since it had the 1 tick mark. H to F, since it has the 2 tick marks. And F to G, since it has the 3. And that was the order we did ABC in. So we're looking for triangle ABC is congruent to triangle GHF. So triangle ABC is congruent to triangle GHF. There is our first blank that they officially have us fill in. So since all congruent triangles are also similar, triangle ABC is similar to triangle GHF. Due to the constructions in steps 1 and 2, along with the definition of a midsegment, it can be stated that GH is a midsegment of triangle DFE. What was it that they gave us in constructed in step 1 and 2? What they constructed was the midpoint. So G was the midpoint of DF. That means that from D to G is also the same length from G to F. So it needs to have the same marking to indicate it's the same length. They also constructed point H to be the same, the midpoint. So that means from F to H has to be the same distance from H to E. And the definition of a midsegment is that it connects the midpoints of two sides of a triangle, which GH does. And it also states that it is parallel to the third side. So GH is parallel to DE. So right here is going to be GH is parallel to DE. Therefore, angle D is going to be congruent to angle FGH. So how? Let's see if we extend these lines, and there's our parallel lines, and here's our transversal. Since they're talking about a point F, I'm going to go along the transversal right here first from F to D, since they talked about point F and angle D. So now we have two parallel lines with a transversal that cuts it. Now this brings in all of our alternate exterior congruent, our alternate interior, our corresponding same side interior. It brings in all of those, and vertical angles it creates. So now we need to find out which angles it's stating. So angle D right here is congruent to angle FGH right here, because they are corresponding angles right there, and that's what it states right here along that transversal. Now they also point out about angle E. They're using another transversal. They're using the transversal F to E. So again, we have two parallel lines with a transversal, brings in the corresponding alternate exterior, alternate interior, same side interior, and vertical angle. So they're stating that angle E congruent to angle FHG by the corresponding angles on parallel lines cut by a transversal, which is true. Now that there are two pairs of congruent angles, it is possible to use the blank to state that triangle DEF is similar to triangle GHF. So they're saying DEF, this big triangle, is going to be similar to triangle GHF. DHF, our little triangle. Since we have our two congruent angles, and that is our angle-angle similarity postulate. Two angles, angle, angle. And it's the similarity postulate. All right. Finally, the blank property of similarity allows that since triangle ABC is similar to triangle GHF and triangle DEF is similar to triangle GHF, it can be concluded that triangle ABC is similar to triangle DEF. Okay, that was our transitive property, if you're wondering what that blank is, to use as an example. Triangle ABC is similar to triangle GHF. Triangle GHF appears here and here. That is our link. So first is similar to the middle. The middle is similar to the last. Therefore, the first and the last have to be similar. So there is your step-by-step with question 8. And it is the exact same one that was set up for question 7, and I had stepped through what those were. So we can, I'm just going to leave these ones up and compare. This one was the segment DF. So this is our first missing one, which was segment DF. So one is segment DF, and in statement 8, it was GH. So segment GH. And we have a different type of proof for question 6. So read and complete the following proof. The following is an informal proof of the side-angle side similarity postulate. Plan for the proof. Construct segment DE on triangle ABC such that DE is the midsegment of ABC. That means that B to D is also congruent to DA. And EC is congruent to EA. And also construct a triangle that IJK such that triangle ADE is congruent to triangle IJK. So that means AD was the same as JI, and the length of AE is the same length as IK, and the length from DE is the same length as JK. Then by the side-angle side congruence postulate. So they used that angle A was congruent to angle I, which is true because they created it to be that way. Then if triangle ADE is congruent to triangle IJK and triangle ADE is similar to triangle ABC, triangle IJK is similar to triangle ABC, then by the transitive property of similarity. Okay, given that segment AD is congruent to segment IJ by construction, segment AE is congruent to segment IK by construction, BE is parallel to segment BC by construction because it was the midsegment, and angle I is congruent to angle A is congruent to angle I by construction. Prove that triangle IJK is similar to triangle ABC. Alright, they listed out our plan, and now they're breaking down the statements. So, right here, I have the first blank. So, angle DEA and angle BCA are blank angles. Definition of blank angles. What are they? Well, since DE is a parallel line and EC is parallel to BC, and AC is our transversal, this angle DEA, and angle BCA, since they are both in the left upper corner on their line that's cut by the transversal, so 1, 2, 3, 4, 1, 2, 3, 4, they're both in that one position. They are corresponding angles. Therefore, they're congruent by the corresponding angles postulate. And so we have these two angles. And if we look here, it says blank of similarity. So let's look and compare the last two statements. Triangle ADE is congruent to triangle IJK. Therefore, triangle ADE is similar to triangle IJK. And triangle IJK is similar to triangle ABC. Blank of similarity. They listed it out in the proof plan right here. Triangle ADE is similar to triangle ABC, and triangle IJK is similar to triangle ABC. So by the transitive property of similarity. So it's our transitive property. And your tip from Paul Wilson's Little Book of Calm, it says, know when to stop. For most activities in life, there are no prizes for perseverance. When you know your stress levels are rising, stop what you're doing. Either take a break or do something else. So when you feel your stress levels are rising, pause, give yourself 5 till you calm down, and then come back and go straight at it. So there's your tip from Paul Wilson's The Little Book of Calm.